Hello everyone. In this video, we are going to discuss about some more concurrency control techniques. Already, as we had discussed in different types of the concurrency control techniques, that is the 2PL, timestamp, and multigranularity. Here we are going to discuss about the validation, multiversion concurrency, and snapshot isolation, and using logs for concurrency control in indexes. So first one here we have a validation concurrency control. Also it is called as a optimistic concurrency control. So here the first main identity of this validation concurrency control, it is free from lock. Means any type of the lock it is used for, not used for the transactions. That is the main identity. So here when multiple transactions are required to execute, that all the transactions will be taking three phases here. One is a read phase and another validation phase, and one more we have a write phase. So in the schedule, we have a multiple transactions. They are coming for the execution T1, T2, and up to Tn. So what it will do, that system, it will be treating that it cannot put any of the log, means it cannot bifurcate the read and write operations here, as if it will be filling all the operations only for the reading purpose. So it will be allowing for all the transactions to execute. So when it is required to execute all the transactions, it will create one of the local copy here. The database data values, the transactions will remain as it is, and one more local copy it will be creating. And within that, it will be storing all the transactions with their original values, and it will goes on updating the values for the transactions as they will take the execution. While execution time, if any changes to the data values, that will be written only for the local copy rather than the database data. So after by confirming whether these are right or wrong, consistent or inconsistent, it is going to write to the database. So still here until to complete all the transactions, they will be writing only to the local copy here. So here we have a first phase. It will be allowing for all the transactions without putting any of the lock. And all the transactions, they will be maintaining their initial values in the local copy. And they will go for the execution. After execution, that those values are required, when the execution it will be completing, it is required to write to the database. That is commit operation it has to take. Before committing, here we have a one more phase it will comes, that is the validation phase. So this validation phase, what it will do, it will be checking all the transactions for their changes, whether these transactions are consistent or inconsistent. Means it will check about the serializability, whether these are the serializable schedules or non-serializable. If they are having the consistency and they are maintaining the serializability, once it is ensured, then only they are going to write to the database. That is the final commit operation it will take. So here we have a read phase. It will be reading all the transactions without any lock here. And those transactions initially, before starting their execution, they will be stored in the local copy. While execution time, if any changes are taken, read and write operation. Say, for example, T1, it is only for the reading purpose, no any modification for the data. T2, it is taking for the writing purpose, then database value, it will be changing. But here it is not going to write it to the database. It will be writing that one to the local copy. First, it will be writing to the local copy. Then when all transactions they are completed, whether they are maintaining the serializability, that it will check in the validation phase. So once it is confirmed, all the transactions are maintaining the serializability, there is no any inconsistency or confliction, then it is going to write it to the database here. So when it is writing to the database, for the read operations, no any changes at all. As it is, it will be writing. And for the write operation, wherever there is a modification, that it will be writing to the database. In this way, we have a three phases: read, validation, as well as write. Very simple it is. Read without lock it is. Validation, before committing all the transactions, that still they are in the local copy, that they are all the local copy data will be written to the database. Before writing that one, it will check for the serializability. That itself it is called as a validation phase. If all the transactions they are maintaining the serializability and they are consistent, then it is going to write those operations to the write phase. That is that they will be writing to the database here. So these are the three phases it will be taking. Then now here we have a question is validation phase. So how it will check for the serializability, how it will be checking for the consistency. Here we have a two conditions in order to check whether the data it is valid or invalid, means the transactions are valid transactions or invalid transaction. Here we have a two condition. One condition is that when T1 and T2 they will be executing, multiple transactions are executing. Suppose for example, now you may assume that the T1, this is the first transaction which it is executing, and after completion of that T1 only, the next transaction T2 it has to execute. Or you may take any of the transaction TI it is executing, and after completion of the TI only, it has to go for the TI plus one next transaction. So here we have a, just you have to assume this is a transaction which it will be executing. TK is a transaction which it is executing. And before starting the next transaction TI, it should be completed. Finish TK before starting the next transaction TI. This is the one condition. Means that will say transaction is serializable when it will be satisfying any one of these two conditions. First condition is that first transaction should be completed before starting the next one. This either it has to go for this one, like that any of the transaction it is taken right now, after completion of that only it has to go for the other transaction. This is one condition. And one more condition, or one more, it has to satisfy either that one or this one. One more what it will say, so already we have a one of the transaction it is executing, TK it is a executing transaction, still it is not finished. At the same time the transaction TI it is started. Means one of the transaction it is executing, before completion of that transaction only, next new transaction it is started. So here we have a, it is allowed, but only when it is allowed means at least before starting the validation phase of the next transaction, the previous transaction should be completed. Means now we have a T1 it is executing, and before completion of this T1, T2 it is started. So T1 it is completed here, read and validation as well as write. So when it is writing, T2 can start its read. But when it comes to the validation, before coming to validation phase of the second transaction, the first transaction should be completed. That is the condition. Means now here we have a second transaction, it is started before completing the previous transaction. TI it is a second transaction and TK it is a first transaction. Now here we have a TI, it is started before completing, before finishing the TK. But here we have a finished TK is less than validation phase of the TI. Means it should be completed, TK should be completed before starting the validation phase of the TI. Yeah. Second transaction is less than the first transaction. Before completing the first transaction, second transaction, it is started. But second transaction validation phase should be greater than the finishing of the previous transaction, or the previous transaction, first transaction finishing stage should be less than the validation of the TI here. So here we have two conditions. Either one transaction will be started after completing the previous transaction, or one more is, or else already one of the transaction it will be executing. Before completion of that, it may go for next transaction. But the condition is when the validation phase of the second transaction it is started, before that it should finish the previous transaction. That is one more condition. Either any one of these two conditions are satisfied, then we'll say it is the valid transaction, and that will be returned to the database. So here we have a, like this, it will be following three phases, and advantages, no locking overhead. That is the main advantage here, and suitable for systems with many reads and few writes. Why? Because in the initial stage, all the transactions are rushed for the execution as if they are reading purpose. If many reads are there, then it will be beneficial because there is no much updates and no overburden for checking the serializability. But that only if we have a more writes, then for each and every transaction, it is required to check the serializability. So avoid deadlocks. It will be avoiding the deadlock. These are the different advantages we can notice. And disadvantage means if conflicts are frequent, rollback rates increase. Means here we have a confliction, reducing efficiency. If the transaction is not ensuring the serializability, then there will be the confliction. So when there is a confliction, that it will be rollback. Only the consistent transactions are returned to the database, which are inconsistent, those will be rollbacked. So here we have a rollbacking, it will reducing the efficiency of the CPU processor. Not ideal for write heavy workloads. Means in this one it is suitable when we have a more and more reads rather than that of the write operation. The next one we have a multi-version concurrency control. So multi-version, here it will be creating the different versions. Suppose here any of the record, multi-version concurrency control is a control technique that allow multiple versions of the data item to exist simultaneously to improve the performance. See, for example, in the table, in relation, if we are going to do any update for the particular record, for example, I may say here the employee salary. I need to increase with a particular employee. Here we have a employee salary will be increased with 1,000 for the particular employee where employee ID equals to this much. In that case, what happens? It will be affecting for the particular row and that record rather implementing that change for the particular record, it will create a duplicated copy of that one. It will be creating the duplicated copy of that record, and for that duplicated copy, that for the copied information, that is a new version, and from where it will be copying, that is the old version it will keeps, and for the new version it will be applying the updates changes, it will be applying here. Like that, it will goes on doing for the multiple records wherever there is a update, it will be performing like this. For that particular record, when it is required the update, it will create a duplicated copy, and for the duplicated copy, that is a new version data, it will be taking changes rather than that of the old one. And old one it will be maintaining to confirm that until it will be maintaining the serializability. If it is maintaining the serializability and it is a consistent, then that higher version it will be stored and old version it will be removed here. This is the main technique of multi-version concurrency control. Here the record which it is required to update, before updating it will create its duplicated, that is a new version of that record, and for that new version it will take some changes. So here we have a read operations cannot block the write operation. Read operations do not block write operation and vice versa. So here we have a three phases here also, that is the read phase, write phase and cleanup. So read phase, what it will do, it will create a new version of the data to which it is required to read. Latest version of the data as the start time. Means the recently reading data is nothing but a latest version. And write phase, instead of writing data transactions, create a new version. So here we have a which of the data it is required to update, its new version it will be creating. That copy data it will be creating. Then next we have a cleanup. Cleanup means that now finally when it is confirming that it is the valid data and it is maintaining the consistency and correct updates it has taken, it is required to remove all the old version data. Means from where it is copied the new version, updated version, old version it is the initial phase of that one, that it will be removing. That cleaning of this old version, removing of old version is called as a cleanup phase here. Older versions are removed when no active transactions need them. Means that they are like a garbage, they will be cleaning from the memory here, database. So here we have advantages of this one means here we no locking is required. That is the main advantage. Even for the previous also the same it is. And readers never block writers. So readers they will be performing the read operation. They cannot be affected for the writers because only for the write operation it will create a new version and it will be applying the updates. Readers can be maintaining their values as it is. So provides better support for long running transactions. And disadvantages, storage space, it is required more here. Why means wherever there is an update, we have to duplicate two records it has to maintain. Like that in one database, we have a 50 records are required to update means then 100 record space it is required because 50 old version and 50 new version. So one more technique it is required here, additional technique is required to implement that is the garbage collection. It is also overburden for the processor here. The next comes snapshot isolation concurrency control. So here we have a snapshot. The previous that is multiversion concurrency control, only the record which it is required to modify its duplicated copy it used to create. In case of the snapshot isolation, that it is one of the variant of the MVCC, that is the multiversion concurrency control, ensures each transaction works with a consistent snapshot of the database. Means complete transaction it will be created its snapshot, not only one record here, complete transaction. Now here we have a each of the transaction when it will takes its commit means one of the transaction it is started its execution after completion of the entire transaction it will goes for the commit. The final stage it is the commit means it will be writing to the database. After commit only that data value it is allowed to use for the other transactions. So here we have a one of the other transactions are required to do any modification for that data value. First, it should be committed with the previous transaction. Then only it is allowed to use for the other write operation. Suppose now T1 it is executing and after completion of the T1, it will be reading the A value, A equals to 100. Then after by reading and writing that A value, it will goes for the commit. So after committing that data, it will be writing with another transaction. That other transaction, it will be reading that value that is A equals to 100 and then updates on that it will be taking that is the T2, T3 and all. So here we have a new copy of the data. Means here what happens, the previous transaction T1 when it is completed execution and committed, it will create its snapshot. Means duplicated copy of its that complete transaction it will be created. And for that duplicated copy of the transaction, that other transactions can go for the writing. They will be modifying the value. Means whatever the value it is modified, it will be applied for the snapshot here. That is a new version snapshot what it will be taking. For that it will takes. So here we have a prevents read phenomena like dirty reads and non-repeatable reads. So dirty read when it is occurred means now T1 it is executing and it is given one of the A value A equals to 100, but still it is not committed. Still it is not committed, then other transaction T2 it will comes and it will be reading the same value and continued with the update and it will be writing to the database. If T1 it is rolled back, then what happens? The T2 from where it is taken the value, it is lost. Then it is called as a dirty read here. Means before completion of one transaction, another transaction, it will continue the execution with that previous by reading the value from the previous. So this it is the dirty read, but here it is not possible that it will be preventing this problem here by sharing that value after committing only. So one of the transaction after committing only, it will create its snapshot and for that it will be applying the changes. Even non-repeatable reads. Non-repeatable reads means that one time when it will be reading the data, it will be showing one of the output value. Same data with the same query for the same database we are reading in another different time means again it will give a different value. then it is called as a non-repeatable reads. Means it is not maintaining the consistency. Suppose now I need the employee details, that number of employees who are drawing salary more than 50,000. Now for the first execution, it is given here some 500 employees. Next time again for the same database, I will be writing the same query. This time it will be giving some 100 and all. So here some insertion deletion operation it is taking, third party operation it will be taking. That it is called as a non-repeatable read. That is prevented from this. Then here we have advantages of snapshot isolation. No read locks. Here also there is no locking problem at all. No lock it is applied. And here we have a eliminates phantom reads. Phantom reads in the sense that only, that repeatable read. That is dirty read, repeatable read. It is called as a phantom read. Phantom read means now here we have a for one query, for the same database, for the same relation, it is showing some output, 5 records output. And the same query next time again we are applying for the same database relation, then it will be showing 10. That is called as a phantom read. Means while reading that inconsistency of the data. Means for the first read as well in between the first and second read, some modification it has been taken. That should not be allowed here. Then next here that it is not occurs in this type of the concurrency control. Then disadvantage means here we have a can lead to the right skew anomaly. Right skew anomaly means that it is very opposite to that of the phantom reads. In this case, what happens after committing the transaction TI, it will be creating its snapshot. There just we have some value a equals to 100. This is the output of that transaction. Then here other transactions, they will be waiting for that one. And suppose now we have some two transactions. Now T1 it is completed, its snapshot it is taken. T2 and T3 are waiting for the same data value. Then both will be rushing and same data value it is used by T2 as well as T3, a equals to 100. Then T2 it will be adding 100 and T3 it will be having 200. Then a equals to a plus 100 means in T2 it is the 200. In T3 it will be a equals to a plus 200 means 100 plus 200, 300. Now T2 200, T3 300. That for the value a. Then in database, which one it has to write? Either a equals to 100 or 200 or a equals to 300. This problem, it is called as a skew, right skew anomaly. Means same data value in two different modes it will be updating. That problem we may notice here in case of the multiversion concurrency. This one, in this concurrency control technique. So here we have a example it is given how to understand this skew anomaly. Then next here we have a using logs for concurrency control in index. So here we have a indexes speed up queries, but they also require logging mechanism. So here we have a records which we are maintaining in the database. For that we have an index. When there is an index, the query will be executed very fastly. But when we have an index, we have to go for the locking mechanism. Otherwise, it will lead to the inconsistency. So here we can notice the different types of the logs here, index logs. One is the key value locking. Key value locking means now we have a 1 to 50 records are there. So 1 to 50 records, if we are deleting some in between records, the deleted identity it has to keep here. Once the record it is deleted, then no any identity for that record it will be remaining. That's what here we have a one of the log, that is the logs individual index keys to ensure the consistency. Means here what it will do, wherever it will be deleting the data, rather deleting data, that data it will be locked. Means some identity it will be giving here until to confirm the consistency of the transaction. That is the key value locking here. And then here we have a predicate locking. Predicate locking means here locks a range of values to prevent a phantom reads. The phantom reads means that only here we have some repeatedly when we are reading the data, we'll get the different types of the outputs here. So here we have a predicate lock, means by using some predicate logic and all, we have to go for the complex queries to maintain that intervention of the third party. When that reading operation it will be taking for the data, first time, second time, multiple times, it has to maintain the consistency and same output it is required to give. For that, it will be using some predicate logic here to lock the data and all. And next one here we have a gap locks it will takes. Locks gap between index values to prevent inserting new records in that range. Suppose now we have a 1 to 50 roll numbers are there. Some of the students they have left in between. Some we have a 10, 12, 15 they left. Then what happened? That for that gap, no other record should be inserted. No other information should be inserted. That should be prevented here. That is the gap locks. So here we have a through index, it will be maintaining the consistency of deletion as well as consistency of inconsistent read operation as well as that intervention of the information, additional information, extraneous information. So here we have the index locking example. Suppose now salary is greater than 50,000. So 50,000 one time we are reading, it will be giving some output. And here after that, after by reading one of the user, here we have a salary equals to 60,000. It is inserted for the same relation. Next time again, if we read means this also it will be added to this one. So that number of records will be increased. That it will shows the inconsistency. Here we have a best example for this is B tree indexing as well as hash indexing. So these are the different types of concurrency control techniques. I hope it is clear to you. Thank you for watching.